Hello everyone, this is Mr. Teen Tutor here, and today we will be talking about tangent planes. Before we start attacking this problem, let's think back to Calculus 1 and 2 first so that you guys know what you have to do in order to solve this problem. In Calculus 1 and 2, when we were dealing with functions of one variable, there were questions that asked us to find the equations of tangent lines at certain points on a certain curve. So let's take this curve here for an example. F of x equals 3x squared plus 5. This is a parabola. You learned in Calculus 1 and 2 that in terms of expressing a tangent line equation, it's very much like point-slope form. It was y minus y1 equals the derivative at a certain point, that is your slope, times x minus x1. So let's just finish this problem right here. Let's say we wanted to find the tangent line at the point 1, 8. So first we would find the derivative of this function with respect to x, and that would be 6x. And then we would plug in the x value of 1, since that's the coordinate, and we want to find the tangent line at this particular point, and we get f of 1 equals 6. And so then your x1 is your 1 and your y1 is your 8, so then we just put it into the equation. It became y minus 8 equals 6 times the quantity x minus 1. X minus 1, not 11. Of course, you can rearrange it if you want, but I'm just going to stop there because, again, I want you to see how we did these problems in Calculus 1 and 2. Now, this problem that we're doing right here, this is a function of two variables, so now we are in 3D. So rather than having tangent lines, we now have tangent planes. And so the equation for the tangent plane, the general form, is a little similar to this, but a little different. Let me erase this problem first, and then I will write out the general equation for a tangent plane. So here's the equation of the tangent plane in 3D. It is z minus z sub 0 equals the partial derivative with respect to x times x minus x sub 0 plus the partial derivative with respect to y times y minus y sub 0. In terms of differences between this form and the other form you worked with in Calculus 1 and 2, we are dealing with partial derivatives in this case. In Calculus 1 and 2, you worked with functions of one variable, but now you are working with functions of two variables. Therefore, we had this term partial derivative. So this point right here, we're trying to find the tangent plane at the point 1, 2, 18. So those numbers would be x sub 0, y sub 0, and z sub 0 respectively. But what we need to do first is we need to find the partial derivatives and then find their numerical values. First, let's find f of x. So if we look at this function right here, we only focus on the terms with x's in them. So in this case, it's the x squared, and then the 3y squared and 5s are treated as constants. As you know, think back to Calculus 1 and 2, the derivative of a constant is 0. Therefore, for fx, we would just have 2x. For the partial derivative with respect to y, let's look up here again. This time the x squared is treated as a constant, and again the 5 is treated as a constant. Therefore, we just focus here because the derivatives of these two constants in this situation will be 0. So when we look here, think back to power rule, it's just 6y. Now we know the x value it's 1. So plug in 1 for x and you get 2. So for the tangent plane equation, f of x will be 2. Let's look here. The y value is 2, so plug in 2 there, you get 12. And once you do that, we can write out our equation. Z minus 18 equals 2 times x minus 2 plus 12 times x. Oh, I'm sorry, I made a mistake here. This shouldn't be x minus 2. This should be x minus 1. And this one should be y minus 2. There we go. So our final tangent plane equation is z minus 18 equals 2 times the quantity x minus 1 plus 12 times y minus 2. And that's it. That's how you find the equation of a tangent plane. So all in all, it's really not that hard. Again, the only difference between the tangent line equations you work with in Calculus 1 and 2 and the tangent plane equation you're working with here is that you're dealing with partial derivatives. So you need to make sure that you calculate those partial derivatives correctly. If you don't, then you will get them wrong. Alright, so I hope this video helped. I hope you guys understand now the differences between the tangent line equation in Calculus 1 and 2 and between the tangent plane equation in Calculus 3. Alright, thank you for listening, guys. Mr. Teen Tutor out.